Okay, we're going to do some factoring here. So we'll start out with something fairly simple. If you want to factor trinomials, I prefer the trial and error method. So basically what you have to do, you want to try to factor this trinomial in two binomials. And so what you're going to have to do is say, well, the first term will factor into 5x and 3x, or it'll factor into 15x and x. And then you figure out what's the last term factor into. Well, there's several things the last term can factor into. Since it's minus, it could be a -2 and a +4, or it could be the opposite signs, +2 and -4, okay? Or it could be, what else? 8 and -1, right? So, or -1 and 8, or it could be +1 and -8, okay? Well, the trial and error method basically says this. If you try something, all right, I'm going to try something that I know is not going to work here. So like, let's say I tried 15x plus 1 and x minus 8. Okay, well, if you check this by the FOIL method, here's what's going to happen. You know you're going to get 15x times x is going to give you 15x squared. And then when you multiply 15x times -8, grab your calculator if you need to, but you're going to get -120. You're going to get -120x. And then when you multiply 1 times x, you're going to get 1x. Okay, well, do I need to go further? Because I know -120x plus 1x is not going to equal -14x. So I know that's not going to work. Well, I could try 4 and -2. Okay, let's give that a try. So 15x times x is still 15x squared. Well, 15 times -2 is going to be -30x. And then 4 times x is 4x. Okay, well, what happens if I combine these two terms? I don't get -14, I get -26x. So that's out. Well, since I didn't get anywhere close with 15 and x, so maybe I'll try 5x and 3x. Okay, so now if I do that, let's see what I get. If I do 5x plus 4 and 3x minus 2, 5x times 3x is 15x squared. 5x times -2, that's minus 10x. And then 4 times 3x, that's 12x. And if you combine minus 12x plus 10x, minus 10x plus 12x, you don't get minus 14x. So why don't we switch the numbers? How about 5x plus 2 and 3x minus 4? Let's switch them around. Okay, so because, see, 2 times -4 is still going to give me -8 for the last term, right? So that's really the main thing. Just make sure we keep the terms that's going to give me 15x squared and minus 8, and then just keep working until we find the right combination to give me the last term. I mean the middle term, excuse me. So now 5x times 3x, just like it was before, is 15x squared. 5x times minus 4, that's going to be minus 20x. Okay, and then 2 times 3x, that's plus 6x. And let's see, what's minus 20x plus 6x? I believe we got it. That's going to be minus 14x, and then of course 2 times -4 is going to be minus 8. So that's how I came up with the factors, just trial and error. And so I got the answer 5x plus 2 times 3x minus 4. Now, there is a more scientific method that some people might teach you by using numbers that add up to give -14 and numbers that multiply to give -8, and then you have to factor by grouping. But let's not talk about that right now. Okay, now there's also formulas for factoring, but sometimes the formulas are kind of hard to see. Okay, let's say I wanted to factor this. Okay, well, if you factor this using a formula, you would have to recognize that it fits the formula. Well, generally, if the first term is a perfect square, like 9x squared is a perfect square, and the last term in a trinomial is a perfect square, then there's a good chance that you've got a binomial squared. Okay? Not always, but it could be. So, if the first term is a perfect square and the last term is a perfect square, well, the middle term's got to be a particular format. The middle term has to be double the product of a and b. Now, not a squared, b squared, but a and b. So, if you take a look at this, what's squared to give me 9x squared? 3x, right? And what's squared to give me 25y squared? 5y. So what I have to do is multiply these together, 3x times 5y, and I get 15xy. And then I have to look at this middle term and see if that is double 15xy. And actually it is. It is double 15xy. And if you look at it, I can actually show you here. See, 3x quantity squared, 9x squared is the same as 3x quantity squared. And 25y squared is the same as 5y quantity squared. And then this 30xy is actually double or twice the product of those two roots, 3x and 5y. So once you recognize that, then you know this can be written as a binomial squared, 3x plus 5y quantity squared. Now the only difference, if this was minus right here instead of plus, the only difference would be is this would be 3x minus 5y quantity squared instead of 3x plus 5y quantity squared. Okay? Now, make sure you understand, just because this is a perfect square and this is a perfect square, it doesn't mean that this is going to be a perfect square trinomial. Again, that middle term has to be of the proper form for it to be a perfect square trinomial. Okay. Now, another formula that we can use is called difference of squares. So anytime you have a perfect square, like here, x to the fourth is a perfect square, minus a perfect square, then you can factor that in a formula called difference of squares. And that works like this. If you have a squared minus b squared, well, that factors into a plus b times a minus b. And you can do the a minus b first. Doesn't really matter which order. So, this is x squared squared, right? So x to the fourth is a perfect square because it's x squared squared. And 16 is a perfect square because it's the same as 4 squared. So this could factor into the square root of x to the fourth, which is x squared, plus the square root of 16, which is 4, and then times the square root of x to the fourth, x squared, minus the square root of 16, which is 4. And so now we can pat ourselves on the back and say, okay, we factored that into difference of squares. But here's something that I did to you, because I'm trying to make these problems a little more complicated than just your normal everyday problem. Okay, if you look at this, this x squared minus 4 is also the difference of squares. So we could actually factor this further. Now, this is x squared minus 2 squared. Well, x squared minus 2 squared, using the same formula, would factor into x plus 2 and x minus 2. Now notice I did not factor x squared plus 4 because x squared plus 4 will not factor. There's no formula for a squared plus b squared because that won't factor over the reals. So x squared plus 4 will not factor. Another formula that's handy, and I'm going to do it with a sum, you could also do it with a difference, is when you have the sum of two perfect cubes. Well, 125 is actually 5 cubed. Y cubed is just y cubed. So this 125y cubed is just 5y quantity cubed. And 8 is actually 2 cubed. Well, if you have a cubed plus b cubed, there's a formula for factoring that. And the formula is you take the cube root of the first term plus the cube root of the second term. So, and then you take that cube root and square it, and then over here at the end you have the other cube root squared, but in the middle you have minus the product of the cube roots. Now you got to get your signs right, because if it's a cubed plus b cubed, the binomial is plus, but the trinomial has the middle term minus. If it's a cubed minus b cubed, the binomial is minus, the trinomial, the middle term, is plus. Alright, so let me see if I can show you here. Now you don't have to do this second step, but I'm going to show you. I'm just showing you that this is the same as 5y quantity cubed plus 2 cubed. So 5y is the a in this formula and 2 is the b. So if I do a plus b, then I would have 5y plus 2. Now if 5y is the a, what would a squared be? Wouldn't it be 5y quantity squared, which is 25y squared? And then what would ab be? Well, wouldn't it be 5y times 2, which is 10y? That's supposed to be a minus right there. Okay, got to be careful. That's a minus. So it's minus 10y. And then plus b squared, so that would be 2 squared, which is 4. So this factors into 5y plus 2 times 25y squared minus 10y plus 4. Another way to factor, and this is usually when you have 4 terms. When you have 4 terms, group the first 2 terms together and then group the second 2 terms together. And then look in the first 2 terms and see if there's a common factor. So in these 2 terms, I can factor out an x squared. So if I factor an x squared out of these 2 terms, I get x squared times 5x plus 2. And then in these 2 terms, see if you can factor out something out of this. And since this is a minus, let's factor out minus the common factor. So I know 9 will go into 45 and 18, so let's factor out a minus 9. So if I factor out a minus 9, I get minus 9 on the outside, and then that would leave me with plus 5x plus 2 on the inside. Okay, now look at this. Look at what I have. Look in this factor. That term, I'm sorry. Look in that term and look in this term. And what's common to both of those terms? Isn't it 5x plus 2? See, here it is again. Here's the term. There's the first term. Here's the second term. So in both of those terms, I have a factor of 5x plus 2. So what happens if I factor the 5x plus 2 out of the first term? Okay, what would happen? If I factor it out of the first term, I'm just left with the x squared. But then if I also factor it out of the second term, I'm left with the minus 9. Now again, don't pat yourself on the back just yet, because when we say factor, we want you to completely factor. And notice that this x squared minus 9 actually can be factored again into x plus 3, x minus 3. So when we finish that, we have 5x plus 2 times x plus 3 times x minus 3. Now I know that was really just a mini lecture on factoring, but on these problems I'm assuming that you have some concept of algebra. I'm going to show you how we can use these factoring techniques in the next video to solve equations.